Well, two of the things we don't do here are amateur radios and SSB radios of any description. So here's an amateur SSB radio. I'm doing this because it's a friend of ours. He wants these evaluating with a view to the possibility of purchase. So I've got a box of 4 of these that don't work, and my job is to evaluate them. I mean, if they're easily fixable, I'll fix them. So to that end, I've downloaded this. Did I say it's the Yaesu FT290R? I've downloaded something I can find on the net, which at least gives me a circuit diagram. And over the pages I've printed off, that might even be big enough to see. So it's not going to get aligned, even if and get it to work. And that's I might be able to pop it on frequency, but that will be where it ends. So this one comes in a mounting cradle. I don't even know how you get it out. Oh, there's some levers. See, I've got no desire to own amateur radio equipment. I like to either use business radios or stuff I've built from scratch. So that's me. So it's powered up from that, and it's got a PL259. So we're going to have to not use that cradle, and what we're going to have to do is to find a lead to fit. So we'll pause the video. That was quick. Well, I'm glad I checked about that. I've made a lead up. I hope it's the right plug. We'll soon find out. I've put FT290 on it because unusually the barrel is positive and the centre is negative. So I'm glad we checked that. It does go in the hole, so hopefully that will make contact. And we'll plug that into the test set, although I think I'm wasting my time. So it's Bank Holiday Monday, so I'm not doing any commercial jobs. I wasn't actually going to do anything. G2 BUC leads. Right. So we'll put our trusty crocodile clips on that. We're on our 2.5 amp power supply. We've got one mic between the 4 of them. Well, this one's lit up. Well, that's a start, isn't it? So it's got a loose knob. So we want it to FM. And that'll be 145 dead. So let's see what happens. If I go over to our test set, I think these are only about 2.5 watts, so I think our 2.5 amp power supply should be sufficient. So we'll go over to frequency counter on that and select picture in picture, and we'll key up. Well, that's spot on, isn't it? 145 dead. So let's check deviation now. Normally, of course, we're on 27 megs, so we've got to change this considerably. So we'll set the it's there somewhere. Out there, Wallow, 1 2 1 2 1 2 1 2 1 2 1 2 1 2 1 2 1 2 1 2 Wallow 1 2 Wallow. So that's 5 kilohertz, which is where it should be for 25 spacing. So it is transmitting. It's transmitting fine. and it's doing 2.5 watts. So that seems fine. So now we'll go over to receive. So we'll just put that into the signal generator. He said he felt the one in the cradle was the best of the bunch. If I had a roof aerial, I'd be able to go 145 for a copy come on, wouldn't I? I've probably said before, I've just kind of never got involved with 2 meters. I'm a 77s person. Okay, so we've got on the signal generator, we have got 145. So let's see whether the radio will hear that. And the answer is yes, it will. So we'll put the cyanide meter on, and we'll plug the test instrument into there. And I hope it's got an earphone socket. Extension speaker goes in there. Turn the volume down. And let's have a look at the cyanide meter. So I'll make a note of these. Yaesu FT290s. So the first one is 0213. So it's frequency, we'll go back to that. Is 145.00021, so it's spot on. Power 2.5 watts. Deviation 2.4 kilohertz. RX for 12 dB, which is where we are, it's 0.56 microvolts for 12 dB cyanide. So I'd like it a bit better than that, but oh, I wonder if it's got RF gain on it. No. So that works. We've no test for SSB. Right, so we'll put that one down and pause the video. So moving on to our next one is 1345. So once again we will plug it into the aerial, put that back to there, and power it up There. Switch it on. I've got nothing coming out of it on receive. But I have on an external speaker. So, how do you work this? Sounds off frequency, that. You can hear the signal range on 5.025, but not on 5. Okay, here goes. Frequency. Yeah, it's off frequency. Let's have a look together at that. So it's 144.98102. Power is 2.8 watts. Let's have a look if we can do that frequency easily. Oh, specifications. Yeah, it's supposed to be 0.25 microvolts for 12 dB, so that other one was a little on the deaf side, which I've no doubt a retune would sort out. 2.5 watts. Right, well, I've downloaded another bit of service manual, and I'll see whether that. I haven't printed it, I haven't bound it together yet. It just came off the printer. Turn the volume down a bit. Yeah, so it's not just one thing you have to adjust. I could have guessed it was going to be a faff. So how do we know which is which model? Probably it's model B. So 1, 2, 3, 4, 5, 6 steps to put it on frequency. I've got the VCO. Don't see any reason to do that because it's working. So we need to take whichever lid it is. Oh, that's what's wrong with the speaker. It's got no wires going to it. That was easy. So we have to take that lid off, do we? Usual Japanese earwax. So what they want us to do is to put the frequency counter onto the cathode of diode 3002 or diode 3003. Which is down there. So I will do. Move that out of the way. Okay. So what we should have is 1341900. So it's dropped as crystals do. Now these sets are about 1981, aren't they? So they're as old as the CB radios we work on. So I'm not going to alter any presets at all. So we need to adjust L3007, which is that one, for 134,190. Well, I'll tell you what, I bet this is going to need a new crystal. And are they going to want to spend 30 quid having one made? I'll tell you what, it's come up. 13419. Whoa. Yeah, well, I think we can safely say that's as near as we're going to get it. I suppose I could just touch it. I'd rather have it slightly higher than low. So then, turn the clarifier switch on. Yeah, have done. And rotate the main knob one click counterclockwise. Yep, done that. Adjust for 1341899 VR 3001 and 3002. That's those two. So why two? One, three, 4, 1, 8, 9. So is one fine on the other course? One, three, 4, 1, 8, 9, 9. 1, 8, 9, 9. Yeah, that's like coarse, and this one's finer. One, three, 4, 1, 8, 9, 9. And that's what it says. So if we take the clarifier off and go back to where we were, it says go backwards and forwards until no improvement can be had. It's 134.189. 134.190. So we'll just pop that down a bit. One, three, 4, 190. Clarifier on. Back a peg. And we should have 134.1899. One, three, 4, 1, 8, 9, 9. Yeah, I reckon we have. So that now tells me, I'll just take that off, that we should have it on frequency. So 144,99934 sounds pretty near to me. So we'll carry on now with that. trouble with these jobs is because you've got to read up the manual, it all takes time. That's what had to be done on a bank holiday. So it's now, just prove it, 145000 something. Yeah. So that and now when I change the frequency, it goes off frequency, which is what you'd expect. So we'll just check deviation. One, 2. 4.8, what am I doing? 4.8 on here. And the receive. Go up to the synod meter. .7 microvolts for 12 dB synod. If I can quickly go through the FM side of the receiver, this could benefit, I'm sure. T1013 is the discriminator. I'm not going hunting, you know. So it's that one there. So put the oscilloscope on and select the oscilloscope. Put an S9 equivalent signal on. Turn the volume up a bit and just make sure that that's at peak. Wasn't far out. And that's now brought this, let's see where it's brought the sensitivity. It's still the same, right. So very quickly, I don't think, do these have any value at all, these radios? Is it a bit like doing a Fidelity 1000 because they're so old? I really don't know. I don't know if amateur radios like latest models only because it's full of bells and whistles. RF coil alignment 1001 to 1004, 1001 to 1004. 2, 3, 4. It's in that line there. 1, 2, 3, 4. Now I'd have said on a stack of Bibles that they were to do with the transmitter from where the position is. Okay. So we'll drop the signal on the signal generator. Wouldn't say there's any stunning change there. So let's go back and look at where we are now. So for 12 decibels cyanide, we're now at 0.5 microvolts, which is about in line with where the first set was. So I think that's, you know, kind of good enough for us to. I don't know where the speaker connects to. Anyway, at least it's on frequency. Internal speaker. Not working. Seeing as this is evaluation, we need to be cutting it down to 15 minutes. Anyway, that does at least work. So we'll move on to that third one. I think it's afternoon tea in 15 minutes. There must be a way to not have to spin that dial a million times. Is it dial? No. I wonder if it's step. Oh, hang on, we're not in FM. That's better. Oh 0855. Okay. So we'll put the camera back on the frequency counter, switch that back to internal, and here goes. I think we'll just pull that one up a fraction like we did the other. It's just that little bit worse than I would like to see. Why can't I get the lid off? Because I'm taking the wrong one off. No, I'm not taking the wrong one off. That's the lid with the batteries. It must be that lid we take off. Yeah. Okay. So bring the probe back for the frequency counter. Pull those wires out from there so we can get to that diode. That on earth, that on the diode. Switch that back to internal and bring back that bit of service manual. So we're on FM, and we should be looking at 134.1. That's not right. Oh, it's on 5.5, that's why. There we go. So it should be 134.19. One 134.190. Switch on the clarifier. Drop it down one peg, and we should now have 134.189. And that's actually correct. But we'll just adjust. Oh, it's a 1899. There we go, 1899. Then we'll go back, so put it back on frequency, take the clarifier off, and we should be back on 134.190. So that's brought that on frequency. It's just that little bit lower than I would like to see. So it was 144.99. So we've done that to 145. Just go back into transmit. 9996. 9998. So the power output, let's go back to that meter. Is 2.2 watts. Might just be able to bring that up quickly. I'd like to have seen it a little bit higher. RF power stage. very quickly T2001 to 2006. It's not going to be those. TC2001 to TC2006. It's going to be those. Right, we'll key up. We'll go to the very final one of these. Yeah, it's no different. So it's these 1, 2, 3, 4, 5, 6. So just make sure these are somewhere near. No, it hasn't brought it up as much as I would have liked. So we'll start off with these. But nothing changed. No change. No change. No change there. Just go through these again. So we're now at 2.4 watts. And that'll do. So we'll plug the extension speaker in. Tell you what, we'll put that cover back on. Put the cover on, it won't need any more adjustment. And now we'll look at the synad. Oh, gone and knocked the frequency on the signal generator. So let's have a look what we've got. .65 microvolts. Better just improve that. So we'll start with that detector. So we'll go back to looking at it with the oscilloscope. It's the one they've hidden, isn't it? That's spot on. don't think we made any improvement there, but we'll just check. I have actually. That's interesting. 0.52 microvolts for 12 dB. So, you know, they're all coming out the same, aren't they? About 0.5. So I've got no experience about these type of things, you know, and how well or what they work. And I appreciate that these are as old, if not older, than most of the CB radios that we get to see here. I'll just turn it off, seeing as it's going through an annoying stage. Let's put some screws in the back of this one and pause the video. So here we are with the final one. Oh, I can't even see a serial number. It's lost its feet off the bottom. Is this a pre-production one or something? So we're going to call it R3 290 because that's what it says engraved there. Now, if that's got an FCC ID, is this an American one, which shouldn't be in this country? The plot thickens. Oh, it's got a BNC on the back. That's an improvement, isn't it? Do we have a BNC adapter on this bench? I'll have to get one. Anyway, we'll power it up. We can hear the signal generator, so that's a good sign. Instead of a telescopic, it's got a BNC on the front. Anyway, I better pause the video and we'll get a BNC adapter. Okay, back on to this radio. If you can hear a buzzing in the background, it's the ultrasonic cleaner. I'm just cleaning some records for tonight's record session. Some of you know I've got quite a collection of LP and single records. So, all vinyl stuff. Where were we? We were looking whether we're going to get transmit out of this. I've now put a BNC adapter on it, and we've got 2.3 watts. So, that's fine. We're going to do frequency first, weren't we? So, we can get the pen to switch on. Frequency. Here we go. Again, that needs pulling up, doesn't it? It's that little bit short of what it says on the display. And I'm not surprised, you know, these are the age they are. It's funny that the person who passed them across, just for checking over, says I think there's only one that seems to be working anything near right, so that's probably that one which we didn't have to touch. Okay. So 144.99838. So we want the frequency counter onto the diode down there. I'm guessing this is different, you know, this is a different model. So 134.19, and then we need to press clarifier and go down a peg. And now we should have 134.189. One 134.1899. Let's go out of that and back to and what should we have? 134.190. We have. Good. That was quite a way out actually. So it wasn't far out as far as FM showed, but I presume that other settings to do with SSB, and although we're not testing that, I'm going to set it as the manual says. I'll just see if we can get a bit more out of this transmitter. 2.4. So we now got as a frequency 144.99870. Don't know why that's lower when it reads right on the method day. .99870. Well, we'll tick it down. Power 2.3 watts. We'll do it that. RX. Let's see what receive's doing. Well, we can hear the signal generator. You know, this is the best one. 0.42 microvolts for a 12 dB synad. That's fine. Just going to check that while we've got the lid off. We'll just check that detector, but they don't seem to go out like some CBs do, and like some business radios do. So we'll just do it anyway. You know what? That was out. So I'm glad I checked it. So we'll just do the receive while we're here. Let's go over to the synad meter. No, I can't see it. There's any change there. Let's go back to 12 decibels. See what we've got now. Well, to be honest, it looks worse. It's like 0.48. So there we go. That's 4 sets evaluated. One of them needs a little bit of time on that speaker situation, because I think it's going to need quite some dismantling to get down to the level that you need. Right, so that's covered that. We'll put some. Why is that grinning? It's just bent, isn't it? That. So we're doing on the air test. So this, you're going to see this video. All it is 4 evaluations on the test set, and they all do very similar results. So we've done the frequency on 3 of them. So I'm intrigued as to whether that's meant for another country. It's got no serial number, whether it's a pre-production one, whether it's been extensively modified, or what. I've no idea, but it hasn't got a telescopic aerial. It wasn't the Mark II one a bit like this then? Anyway, We'll do it on the air test with Mr. Chippy when he comes back. He's due back today, and there you go. I think they were about 1980, weren't they? These, so they're now 40 years old. I think they were about £269 at the time, if I remember rightly. I mean, I was licensed back then, but I was, wanting to build my own kit, which is the avenue I went down rather than buying it. So there you are, 4 different FT290s for evaluation, and we've come to the conclusion they all do 2.5 watts ish. And do you know what? I didn't check the deviation on that one, which I will do behind the scenes. And they all receive around about 0.5 microvolts. Thanks for watching.